limit of a function. And basically, we want to look at a number of examples. And one of them is limit as x tends to 2 of 10. And that basically remains as 10. What about limit at x tends to 2 of x? It will give us 2. Because what are we doing? The idea behind what we are doing is if we look at limit as x tends to a constant c of f of x, then it should be f of c. So we replace the f of x with c, what you have done in that example, and that's how we would get the limit of a function. And that means if we have another example, and in this case, I want to get a limit as x tends to 3 of x squared plus 1. Basically, this will be 3 squared plus 1. And that will give us 9 plus 1 is 10. What about in cases like limit x tends to 4 of 4 over 4x squared? That will be 4 over 4 squared, and that will give us 1 over 4. Example number 5. If I was to get the limit x tends to 1 of x minus 1 over x squared plus x minus 2. Now, you note that if we are to replace this, directly it will be giving me 1 minus 1, that will be 1 squared, plus 1 minus 2, which will be 0 over 0. And this is what we call as the indeterminate form. And so when we have indeterminate form, that's when we use what we call the L'Hopital's law. And so what do? We differentiate the denominator and the numerator at the same time, and then we substitute. So I'm going to go through the problem again. So limit x tends to 1. So when I differentiate the topmost part, it will give me 1. And when I differentiate the lower part, it will give me 2x plus 1. And when I replace 1, it will be 1 over 2 plus 1, which is a third. So that's how I would approach that when I get the indeterminate form of the problem that I have. And that will apply in other cases. For example, a problem like the following we want to look at. If we look for limit as x raised to x tends to 0, if I was to substitute this directly, it will be sine 0 over 0, which is 0 over 0, which is again indeterminate. And since it is indeterminate, and then what do we do? So it is indeterminate. So what we do is we get limit as x tends to 0 over cos x over 1. And if you substitute, it will be cos 0 over 1 is equals to 1. So whenever you have the indeterminate form, then what we use is what we call the L'Hopital's rule. There are so many other examples we can think about. We can think about this, where, for example, I have, let me say it's infinity. So if I substitute this again, it will be infinity over infinity, and the infinity over infinity is not known. So what we do is we go through the L'Hopital's rule again, and then it basically means then we need to differentiate 2x squared, which gives us 2x, and ex again remains as ex. If I substitute, I'll get 2 times infinity over e raised to power infinity. And again, that means we repeat the process because it is giving us indeterminate form. I also give you a problem, so it will be 2 over e raised to power x, and that will be 2 e raised to power infinity, which is 2 raised to power 2 over infinity, and any number. Remember that that 1 over infinity is equals to 0. So if you keep that in mind, then that would be the answer. So you note that we have differentiated this twice for us to get the limit. What about if you have other problems like, for example, this? If I said let's get limit x raised to x to 5, x over x minus 5. Now, even if we are to differentiate, even if we are to substitute, we'll get 5 over 0, which is undefined. So remember, this is not indeterminate because it is not 0 over 0. It is undetermined, undefined. So what we say is that limit does not exist. So that is something that we want to keep in mind, and we can go on and on and on using other approaches. We can think of other problems. I can give you maybe 2 more. So if, for example, I was to get limit as x tends to infinity of x squared plus x over x squared. Definitely, if you look at that problem, you realize that if I was to substitute directly, it will be infinity over infinity. So what I'll do is I'll be slightly clever, and I'll write it in a different form. I'll write it as 1 plus 1 over x. And that takes me to 1 plus 1 over infinity. And that tells me that the limit for that would be equals to 1. I could have still used the L'Hopital's rule because infinity over infinity is also tricky. If I was to use the L'Hopital's rule, then it will be limit as x tends to infinity. I differentiate the power, the numerator, it will be 2x plus 1. I differentiate the denominator, it will be 2x. Then again, I go again and differentiate the second time. It will be 2 over 2. And definitely that one will be x tends to infinity over constant, just like our first problem. And that means then I'll stop at that point. So these are some of the examples of how to use limits.